Hello everyone. Today we will discuss about different types of analysis. Here you can see we can classify the analysis according to the force, according to the material and according to the deformations. So according to the force there are two types of analysis. One is static analysis, another is dynamic analysis. So in case of static analysis, force will be constant. In case of dynamic analysis, force will change with respect to the time. So in case of static analysis, force is constant, so the related deflection also will be constant. But in case of dynamic forces, force will not be constant, it will vary with respect to the time. Static forces such as gravity forces, the weight due to the self weight, the weight due to the floor finishes, these forces will be always with the structure, so there will be no change in the magnitude of these forces. So those forces will be the static forces and the related analysis will be the static analysis. But force such as earthquake forces or the wind forces, those forces are not fixed at all. Those forces always dynamic, always changing with respect to the time. Those forces create some vibrations, some harmonic motions. So the analysis related to these forces will be the dynamic analysis. And the next one is the classification of analysis according to the behavior of material. So according to the behavior of material, there will be two types of analysis. One is linear analysis and another is non-linear analysis. So in case of linearity, load will be within the range of elastic deformations. Material will obey the Hooke's law. Stress will be proportional to strain. Superposition principles will be applicable in case of linear analysis. So in case of linear analysis, force will be such that the material can obey the Hooke's law, or material can the forces, the stresses can be limited to the range of yield point or the proportional limit. So in that case, linear analysis can be performed. So the next one is the non-linear analysis. So in case of non-linear analysis, loads are beyond the range of elastic deformations and superposition principles cannot be followed or cannot be applicable. So the in case of nonlinear analysis, the force will be such that the materials are unable to follow the Hooke's law, or the stresses will be beyond the range of proportional limit. So after the proportional limit, the stress and the relationship between the stress and strain is not proportional or is not same. It will be changing. So in that case, linear analysis will be carried out. Here you can see the graph of the stress strain curve. This point we can call it the yield point or the proportional limit. So after this proportional limit, the analysis became non-linear, and up to this proportional limit, the analysis is the linear analysis. And the next classification is based on the range of deformations, whether it is a small deformations or whether it is a large deformations. So in case of non-linear analysis, material is deflecting, material is cracking, but not collapsing. So the deformations within the range of the permissible deformations or allowable deformations. So that range of deformations, whether it is small deformations, whether it is large deformations, but both the deformations will be within the range of allowable deformations or permissible deformations. So small deformations analysis, we can also call it as material non-linear analysis, and large deformations analysis, we can consider it as the geometric non-linear analysis. So material non-linear analysis, whether as the small deformation analysis, because the materials fails to obey the Hooke's law, So in that case, those material nonlinear analysis will be carried out for small deformations, and for large deformations there will be secondary effects also, or those cases will be carried out in the geometric nonlinear analysis. Material nonlinear analysis, we can perform creep analysis, we can perform shrinkage analysis, we can perform compressive strength analysis. These we can perform under the category of material nonlinear analysis. And in case of geometric nonlinear analysis, there will be secondary effects also, so these will be performed under P delta analysis and buckling analysis. So if we summarize that, so the first is the static analysis. In case of static analysis, force is constant. In case of dynamic analysis, force is not constant. So this is the main criteria. The next one is linear analysis, where the deformation will be up to the range of the yield point, where Hooke's law can be applicable. And in case of nonlinear analysis, the Hooke's law cannot be applicable. It is beyond the range of yield point. And next is small deformations. We can perform material nonlinear analysis for that. Large deformations, we can perform geometric nonlinear analysis for that. So these are the summaries. The next is the load pattern and load cases. So in ETABS, there are two options to define the loads. One is the load pattern and another is the load cases. So with the help of load pattern, we can define static load, and we can perform linear analysis with the help of this static load. Those static load we can define under the load pattern option. So static loads are the dead load, super dead load, live load, reducible live load, static earthquake load, static wind load, snow load, temperature load, and many other loads are there in the ETABS software, such as roof live, pattern live, notional load. All those load which we can define by using this option load pattern into the ETABS software, those are the static load, and the analysis related to these loads are the static linear analysis. But with the help of load cases, we can define dynamic load, whether it may be linear dynamic, whether it may be non-linear dynamic. Modal analysis also we can do with the help of load cases. Response spectrum analysis, time history analysis, buckling, non-linear static, all those type of load we can define with the help of load cases into the ETABS software. Now here you can see these are the loads that we can define with the help of load pattern. First is dead load, where we can consider the self weight of all the structural elements such as beam, column, shear wall, slabs. So the self weight of this structural element we can consider under the category of dead load. Under the category of super dead load, we can consider the load of floor finishes such as mortar, such as tiles, etc. Also the furniture loads also we can categorize under the fixed type of furniture, we can categorize under the dead load category. The next is live load. This load we can consider with the help of IS 875 part 3, and reducible live also we can consider with the help of IS 875 part 2, sorry, part 2, not part 3, part 2, 875 part 2 for the live load, where there are different types of live load are mentioned for residential as well as commercial building. Reducible live we use for the buildings with more than 50 stories, or for such high-rise buildings we use the reducible live. So code allowed us to deduct some kind of some percentage of live load for them. But for the small structure such as G+5, G+6, we do not consider this reducible live. We will consider the full live load. Next one is roof live load. Roof live load not as per Indian code. This is as per American code. They do not consider the live load, roof live load for the earthquake forces calculations. So that's why the roof live load are options is separately given by the software. Notional load is as per the NBCC code, that is Canadian code, where some 2% of dead load are considered as horizontal force and as applied in the global X and global Y directions for the changing of size as per the design and as per the site conditions. If there are changing, if there are some mistake or there are some mistake in erection, so the design size was 300 by 600, but the executed size was 298 by 596. So the CG point will change, and due to this CG and the changing of CG point, there will be eccentricity, and due to this eccentricity there will be some additional moment. That additional moment has been calculated by applying this notional load by them, the NBCC people. And after the notional load there will be seismic load. So we can define the static earthquake forces in the load pattern and static wind forces in the load pattern also. Pre-stress final, pre-stress others, these are utilized for post-tensioning cases. Response spectrum we do not define in the load pattern, we define it in the load cases. So these are the type of linear analysis. Static analysis is the linear analysis. Modal analysis with eigenvector and read vector, these are the linear analysis. Response spectrum analysis for calculating the dynamic earthquake forces, these are the linear analysis. Linear modal time history and linear direct integration time history, these are the linear analysis. And buckling mode analysis, these also are the linear analysis. Among these 5 type of analysis, there are these modal analysis, response spectrum and time history analysis is the dynamic analysis. Rest 2 is the static analysis. Nonlinear analysis is nonlinear static analysis and nonlinear time history, that is nonlinear modal time history or nonlinear direct integration time history. These are the nonlinear analysis that we can execute in the ETAP software. Modal analysis will be considered in the response spectrum and also in the time history cases. So after that, initial conditions we will find it in later. Multi-step statics also, and this is auto construction sequence, buckling load, modal analysis with the help of reach vector, and these are the flow chart we can find out here. That is static analysis we can further categorize with linear and non-linear analysis. In the linear analysis there is buckling analysis, and in the non-linear analysis there is geometric non-linearity, material non-linearity and auto construction sequence analysis. In geometric non-linearity there are P delta analysis, pushover analysis, and in material non-linearity there is creep analysis, shrinkage analysis and compressive strength analysis. Then dynamic analysis. In dynamic analysis there are linear dynamic and non-linear dynamic. Under the category of linear dynamic there is modal, working vibrations, response spectrum, and time history. Modal are further divided into two categories, that is rich vector and eigenvector. And time history is the linear modal time history and linear direct integration time history. And nonlinear dynamic is the time history analysis only, that is nonlinear modal time history and nonlinear direct integration time history. Nonlinear modal also called FNA analysis, that is fast nonlinear analysis. So these are the different types of analysis that we can do in the ETAP software. Thank you.